Hello, everybody, and thank you for being here. My name's Ian Vidal, and my presentation is called Making of a Metal Box, the Trials and Tribulations of Coding a Reverb plugin. The way that I'm going to do this is the first half of the presentation, I'm just going to kind of demo the plugin. And the second half, I'm going to run through the story of kind of how it came to be and the different things I learned throughout the process. So as a bit of an introduction before I get into talking about the plugin itself. As I mentioned, my name's Ian. I'm a musician, writer, and software engineer. I live really close by, actually, in Brookline, but I'm originally from Puerto Rico. In terms of kind of my relation with music and tech and everything, I started my life as a drummer. That's where my musical training is in, but I've kind of picked up other instruments along the way. Previously, I also, back home, I played with a bunch of independent bands, and then I also worked as a recording engineer assistant at a couple of different studios back home. In terms of music, I've released one album on a record label, and that was with Clostridium Records with my band, the FSO. That's on CD. And then in terms of what I'm doing right now, I still kind of actively, write, record, produce, and publish my own music on my webpage and Bandcamp. And then finally, in terms of writing, I think the most relevant thing to this presentation is I wrote a series of articles and interviews kind of tracing the history of electronic music production from the 70s until around the 2000s. And that's just based on the people that I was talking to. It could go before or after, but that remains to be seen. But anyways, in terms of the actual, the core of the presentation, this is Metalbox. It is a modulated algorithmic reverb plugin that I coded in C++ using Juice. And that's what it looks like, but I'll show you what it sounds like. That's probably more relevant. So real quick, I'm switching over to a program called Ableton Live. This is a digital audio workstation, so just a program that you can use to write and record your own music. And the actual plugin is loaded as an effect in Ableton Live. So what I'm going to play first, I have this very, very basic guitar loop, and I'm first just going to play it as it is with no effect, just so that there's context. There is a little bit of reverb in this room, so the effect isn't going to be as dramatic for the people here as it is for the people on Zoom, but still. So the effect is off. I'm going to turn it on, but you're not going to, let me lower that, it's too loud. I'm going to turn the effect on, but you're not going to hear anything because of the mix control. So this mix parameter, what it does is it controls how much of the original signal to the affected or processed signal you're going to hear. So right now it's just full, original sound. I'm going to start moving that over so you can hear the effect. So you can tell it sounds a little bit more far away, more diffused. Just as a bit of an intro to describe what's actually happening. What reverb is when a sound occurs in a space, right? That sound is emanating in all directions all at once, right? And so it's bouncing off of every single surface in that space and then coming back. But it doesn't just stop there, because if it did, that would be like a single echo. It keeps bouncing until it decays. So, if you've ever been in a cathedral or in this very same room and talked or clapped or anything, you'll hear that kind of diffusion. So to now go through a couple of the parameters, I'm not going to go through all of them, but I feel like the most important ones at least. I'll first put a little bit more of that affected signal so it's more obvious. And I'll start with the damp control. What this is doing is it's taking the high frequency content and it's going to cut it down so that the sound becomes darker. So I'll just show you what that sounds like. So it sounds like it's almost in a shoebox. I'll put that back. Then one of the most important parameters is the size control. So, if we're assuming that what this plugin is doing is simulating a space, right, where the sound is now happening, then the size is literally controlling the space or the size of the space. But because it's controlling the size, imagine you're a sound in the middle of a room. If the room is getting bigger around you, then it's also getting farther away. So that means that the quote unquote tails or that diffusion that you hear is going to be longer, but it's also going to happen. It's going to take longer for you to hear that affected sound. So if I put it back in the middle and then I lower the resonance, which I'll explain in a second, and then increase the size, you'll hear this delay effect as opposed to that diffusion. But then if I increase the resonance, it'll start diffusing again as it bounces back. So that leads me pretty well into that resonance control. This is essentially controlling the rate at which those reflections are going to be decaying. So when I set it to 0, they literally decay as soon as they come back. But if I set it higher, then they're going to keep kind of bouncing back and forth in the simulated space. I'll skip over mod depth and mod rate, but I'll talk about stability, which is kind of the unique parameter of the plugin. And I'll explain a little bit later how it came to be. But what it essentially does is that it's going to highlight or make more evident some of the innate resonances in this simulated space. So if I start lowering it, you'll hear how the sound is kind of transformed. So it becomes almost like glassy and resonant as the feedback just kind of is left to do its thing. But yeah, that is basically the plugin. I guess I'll end up by mentioning the surfaces. Again, we go back to the room example. That's just controlling how many surfaces the sound is going to be bouncing off of. And it's essentially just a way of reducing the CPU load, because it's not super CPU intensive, but it's definitely more than, the average reverb you'll find.
Are you using a feedback delay network?
Oh yeah.
So that's the number of your delay lines here.
Yeah. Yeah, I'll explain in a second, and I might go into more detail with you later about that. But that is the plugin. So with that said, I think that's the demo, that's the plugin. I think it's important to talk about kind of how it happens, because when you're making a plugin, it definitely isn't just something that happens in a day or a week or a month. It takes a long time. And for me, the process was it's a very winding path, right? Like it wasn't just, ABC. It was a lot of different things that kind of came together and things that I was doing that ultimately ended up leading to this result. But in general, I kind of break down the project into 4 main phases. The first one being learning the theory or the math. The second one being finding the algorithm that I ended up using. The third one being finding the sound of the plugin. And then fourth and finally, it's just how everything kind of came together at the end to actually result in the plugin itself. So as I mentioned, the first phase was having to learn the math, because as I put in the title, it is most certainly not optional. I mentioned to a few people before the presentation, but I tried to get into audio programming for the first time about a year ago. And I had this idea that I could do it without learning any of the DSP or any of the underlying physics and math to it, because I thought that, okay, well, I've done, recording and audio engineering and that kind of stuff. So it shouldn't be too hard, to do, but it was very hard. And I very quickly learned that you just have to learn the math. There's no way around it. So this time around, in the pursuit of doing that, I picked up a whole bunch of books from the Boston Public Library, and they were just a bunch of different things, like whether it's, fundamentals of signal processing or just audio programming stuff, or like physics of sound, that kind of thing. But throughout kind of picking up and reading all of these books, a lot of them, especially the ones that are actually more related to sound and that are showing you different algorithms for processing audio, they use MATLAB to give you algorithms so that you can see them. But I don't own MATLAB. And then I also think it's kind of, if you're dealing with audio, it'd be more interesting to hear it as opposed to just seeing it. So I figured that I could use Max MSP to literally program the algorithms and hear them in real time. And so what I was using to actually program the algorithms, because what Max MSP is, it's a visual programming language where you can connect different audio processing blocks. I was using a framework called Gen tilde or Gen DSP, which lets you actually code the blocks that you're wiring together. So with that, I could read an algorithm in the book and code it and then hear it without needing to worry about too much of like the setting up a foundation for it. So in terms of the presentation, the plugin, I think the first big step towards it was programming the all-pass filter, which for our intents and purposes is essentially the archetypal delay, right? And if I mentioned earlier that a reverb is a whole bunch of different delays or sounds being echoed, then this is like our fundamental thing for building that, right? So very quick, I'm just going to show you what that sounded like, just the first kind of all-pass prototype I made. And what I'm going to play right now, it's the same guitar loop I showed you earlier, and it's going to be that, and then I'm going to kind of fade in the same sound after it's gone through an all-pass filter, and you should hear this kind of echo effect. Oh, that's playing on my computer. A little bit hard to tell, but it is just kind of essentially delaying the sound. Regardless, the second step, once I kind of had that all pass, I've been prototyping a few different kind of audio processors and stuff. That was just one of the ones that I did. And at that point, I wanted to challenge myself to implement an algorithm that wasn't from one of the books that I was reading, that didn't just have like literally code that I could copy over. And around this time, I saw a talk by Tom Erb, who's a really, really cool audio programmer, who's the guy behind SoundHack. They make some really cool, really forward-thinking plugins. But he was giving a presentation, ironically enough, about him building his own reverb. And during that presentation, his first section was just going through all the different algorithms that exist. And the first one he mentioned was one of the earliest algorithms to have been made. It was developed in the 60s by a guy called Manfred Schroeder. And it is very, very simple. It is, he said that a lot of people didn't like it because it's very metallic, but I kind of wanted to prove that for myself, whether it was too metallic or not. So, but anyways, what the algorithm is, to not get too ahead of myself, the algorithm is essentially 8 all-pass filters wired one after the other. So as you saw, I already had an all-pass filter. So it was not too difficult to just Control-D, duplicate them 7 more times and wire them together and then play guitar through it and see what it sounded like. And what it sounded like was kind of weird. It didn't sound at all like what I expected it to. And then I realized it was because I had done it wrong. I had programmed the algorithm incorrectly. So what I'm going to play now is the original algorithm I implemented and then the correct one. And this one, it actually might be a bit good that it's kind of quiet. I'm familiar with these kinds of stuff. Yeah. So what essentially is happening, the original, and you'll hear in a second, so I'll play the correct one, but that is the original guitar loop that's supposed to be coming out the other end. That actually sounds more like a reverb, but that gets the idea across. So essentially, the original one, and I'm sorry it's kind of quiet. I couldn't really set up my computer to work with this directly, but regardless, it was not right. That first implementation was not at all correct, but it sounded kind of cool. Not cool enough to where I wouldn't fix it and ultimately provide a actually working reverb. But I was thinking about a quote by Brian Eno that goes, "Honor thy error as a hidden intention." And I thought, this kind of weird implementation of the algorithm was a gift. So let me try to use it. And what I ended up doing was I made a control that lets you dial in how much of that incorrect implementation you have to the correct one. So on one end, it's working perfectly. And on the other one, it's completely scuffed. And if you set it somewhere in the middle, it actually sounds pretty neat. And that's what ended up being the stability control that I showed earlier. That's essentially what it's doing. So at this stage, I have a prototype, which you can see in it's the first picture there. That's the max prototype that I built. It's missing a few of the parameters, but I wanted to keep it self-contained so I could actually have a screenshot to share. But to my ears, a novel prototype in of itself it isn't a product, right? That's not enough for me to say, well, maybe I should start selling this to people and make it a plugin. But what actually sold me on that was 2 things. The first one being that once I had this prototype, I was using it a bunch. If I was doing guitars or if I was doing vocals or keyboards or anything, I would kind of, put it through the prototype and then get the audio on the other end and record it. because to me, it sounded really neat. And it was giving me something that other plugins that I had and that I had paid for couldn't give me. And I thought, okay, that's pretty cool. Like that's like the first step for me. But just that would be like, okay, well, I like the sound the same way that like when you cook something, everybody likes what they cook, right? But the other thing that really sold me on it was that I was listening to a couple of bands who, might not have had this exact same sound, but they were like using sounds that were in the same realm. To give one example, there's a band called Broadcast who is very famous for putting spring reverbs on all of their recordings. And what a spring reverb is, it's an electromechanical tank that's usually put in a guitar amp, and you can rip one out and just put anything through it. And that's what they did. But it has a very metallic and kind of bright, resonant tone. And then another kind of example that I had found was a band called Public Image Limited. Their guitarist, Keith Levine, is kind of similarly famous for this flanging metallic guitar tone. And although I wasn't trying to kind of ape these sounds or copy these sounds one-to-one, it was kind of giving me this idea that, okay, well, this tone does have applications in the world of music, right? Like it's not just something you can do to mess around. And so at this stage, that kind of gave me a direction to go and say, well, this is the sound world that this plugin is going to inhabit, right? And these are the sounds that I'm going to tune the plugin so that it can make more effectively. And at that point, I had this prototype and I had this idea that I wanted to make a plugin. And that's almost where it would have ended, because at a certain point, I think I was a little bit afraid of going through the whole process again and then failing, similar to how I'd kind of not gone too well last year. And then around that time, I went to the second meetup for this group, and I saw Joel's demo for Grainferno, which is a really cool granular processor he did. And as I'm sitting there kind of watching the presentation, I'm realizing that like it's making sense. Like he's talking about how he made it and all the different things that went into it, and things are registering in a way that I didn't even think that they would. So that was incredibly motivating. I kind of went home from there, and the day after, like downloaded, the framework that I was going to use. I downloaded Juice. I set everything up. And then as I kind of start finally putting all the pieces together, I'm realizing that all of the lessons that I had been learning throughout the process kind of start falling into place a little bit. For example, like having gone through that, month and a half of just reading a whole bunch of really dry textbooks meant that like when I would inevitably run into a problem with like whether it's the code or the algorithm or whatever, I would understand theoretically what was happening, or I would understand in theory, right? Like I could figure out, well, yeah, of course, if this happens, then that's going to happen. And it wasn't just I was stuck going into the forums and asking people that actually knew what was happening. I could do it myself and troubleshoot at like a core level. And then secondly, because I had been using Max MSP with Gen Tilde or Gen DSP and coding my own like audio processors, that meant that I could port the code effectively. Like it wasn't just I had this wire diagram and then I had to actually do all the coding. Some of the coding at least was already done, so that made it easier to implement. And then finally, having gone through the effort of trying to come up with the aesthetics for the plugin and coming up with like, well, what's the sound world that it inhabits, gave me directions for not only like limiting the range of certain parameters, but also when it comes to like the user interface, I took inspiration from some of those records. And it kind of gave me this kind of jumping off point to now finish it up with, And finally, to kind of conclude, because that's about where it ends up here as a plugin. To kind of conclude, throughout the process, evidently I learned a whole bunch of different things, but I think one of the most important ones was realizing that a plugin is equal parts art and engineering. And that's generally kind of the case for just programming in general, but I think it's especially the case when you're making a plugin. Because on one hand, you need to have the programming chops and you need to know the math. Like I said, there's really no way around it. But you also need to have the perspective of a musician to say like, well, what's the use case for this? Like, I have this tool, how are people going to use it? And why would they use this tool over something else, right? And those two perspectives do both bring their own challenges, right? Because the engineering is it's engineering and chance really, but that's what kind of got me to the unique parameter. But then that perspective of a musician is what took me to figure out like what I was actually going to use it for, or what people would use it for in general. And it's also seen in like that tension between, for example, when you're deciding on what's going to be the number of controls, me as an engineer, I want to make as many controls as possible and give you as much control as you can possibly have. But as a musician, I know that if I give too many controls, that's just overwhelming. And it's like, too much choice is oftentimes not what you want as a musician. You want a tool to get out of your way and to let you make a particular sound, and that's it. And anything beyond that point it's pushing it. So that's as good of a place as any to kind of conclude. I am very, very happy to announce that for everybody here, and as a way of kind of thanking everybody, I do have a light version of the plugin that you can download for free at silicaudio.com. Right now it is Mac only, but if you do have a Mac, you can download that, run it, and it should run on any DAW. And then finally, before I open it up to questions, I have my software development portfolio there, my music page, and then my email. If you just have any questions or just want to talk about this kind of thing, feel free to write there. But thank you very much for listening. Hopefully there's some takeaways there, but yeah, I can open it up for questions then.
Thanks so much, Ian. Any questions?
Yeah, go ahead.
I'm wondering if in your textbook research you looked at plate reverb at all?
Yeah.
I'm wondering what it's like to model that, because I always thought it was really interesting how you first of all, it's been a long time since I took a class on this, so correct me if this is correct. That essentially for plate reverb, you pipe the sound signal into, this is for the physical plate reverb, a very large, literally a metal plate. And then the sound waves, I guess, or electrical waves perhaps, are almost like waves in, if you had a pool in like just a pool of water, you drop something in and it like reverberates off the walls electrically of that metal plate you have. How do you model that?
So I think it's really funny that you mentioned that, because when I was doing research on reverbs in general, this kind of algorithm, and this is particularly a serial algorithm, it's focused pretty much just on diffusion. And to make like a full model, you would have a diffusion stage and what's called an early reflection stage. But this algorithm is used a lot to model kind of more electromechanical reverbs like the one you're mentioning. There's a pedal that's meant to replicate a spring, because a spring and a plate aren't too dissimilar. They're essentially a similar concept, but it's essentially a lot of the times you have one of two ways when you're actually trying to do it, right? You either do like a physical model, which is pretty processor intensive, or you kind of fake it by using an algorithm like this to simulate it. And that's generally how I know different people do it. I know some people use what's called, I'm blanking on the term. It's when you take like one sound and impart the frequency content of one sound into another. Oh man, I'll get you that term, but it's essentially a way of like getting the acoustic properties of one sound and making it sound like the other sound has those acoustic properties, if that makes sense. Exactly, impulse response, yeah. There's another word for the actual process that it's called, but that's exactly what it is, yeah. So you would get an impulse response of a plate and then perform this convolution, thank you. So you perform convolution, and that's one way of doing it, yeah. Thank you so much. But thanks for the question.